Hello, everyone, and welcome to today's webinar on unique considerations of building solar in northern climates. We've had a lot of great interest around cold and harsh climates. We thought it makes sense to host a session today and go into greater detail. As a bit of housekeeping before we begin today's webinar, we strongly encourage your questions and your participation. So please drop your questions in the chat, which is in the Q&A located at the bottom of your screen. So just to make sure that it's working, please drop us a little note to say hello. Okay, great. So just to let everybody know, today's session is being recorded. And now I just wanted to introduce today's speakers. So joining us are Adrian Maroli, Director of Business Development for the U.S. with Polar Racking. Adrian has over 20 years of experience in building teams, customer relationships, and developing new markets for business to business. Next, we have Jellica Mendoza, Program Manager, Solar Engineering for PRI Engineering. Jellica has been with PRI for 6 years. She performs subsurface investigation foundation design development and quality assurance reviews for the racking support of solar PV ground mount developments across Canada and the Caribbean. And joining us for today's Q&A, we have Sam Alradi, VP of Operations at Polar Racking. Sam has over 16 years of experience with 1.5 gigawatts of solar project experience. As Polar Racking's VP of Operations, Sam is responsible for driving growth in developing and executing solar project pipelines and profitability. So welcome, everyone. Adrian and Jellica will be leading today's webinar session, and Sam will be on hand to answer your questions towards the end.
Amazing. Thanks, Marlene. So again, thanks, everybody, and thanks for your patience for bearing with us a few extra minutes to get through our technical difficulties. I wanted to just let you know that Jellica and I will be going through a couple of slides for the next 30 minutes. We'll try to condense it to 25 given our tardy start. But we have reserved a good 30 minutes so that we can go to Q&A. So please put in your question marks. You have all the, there's the icon at the bottom of the screen there, questions in the Q&A. Put in your questions. I see Robert's already kind of started, so get a head start and get as many questions as you can. We'd really like this to be interactive and you guys benefit the most out of it at the end. So we just want to give you a quick overview of Polar Racking and PRI Engineering, talk about where we've come from, where we are today and where we're going, go over our portfolio, our services, and then really spend a lot of time talking about the environmental loads for building in northern climates, looking at what solutions you need to be successful in the north and in areas of frost. We'll talk briefly about some O&M and how important that is, specifically with single access trackers. And we'll finish off with a case study on Hurricane Fiona, which hit the east coast of North America in 2022. So without any further ado, I'll jump into Polar Racking. So Polar Racking has been around for over 15 years. We're founded in 2009, so we're going on our 16th year in 2025. We have well over 4 gigawatts of installed projects across North America and the Caribbean. We have service teams located in Canada, the US, and overseas to help. But more importantly, we take a lot of pride in our manufacturing, and we own all of the QA and QC in Canada, overseas, and over here in the US. So yes, we are 100% compliant with domestic content for your IRA for all of our suite of products, which include single access tracker, the fixed tilt solutions that we have, carports, agrivoltaics, which is growing in our portfolio, and all of the foundations we do make in-house. So if we were to look really briefly at our branding of our products, so Core is essentially our utility size and community solar projects for fixed tilt. We've had this product for a long time. We're very, very prevalent in all of the markets across North America and the Caribbean. Core Flex is our pre-engineered solution for projects below 1 megawatt, and is also available through distribution in Canada and very soon in the US. SolX is our state-of-the-art single access tracker, which actually has the capability of covering undulated terrain with up to 30% slopes with zero requirements for grading. So we definitely stand out in the crowd of trackers with that capability. Shield is our product of carports. All of our carports are extremely customizable and actually 100% customized. It's a part of our portfolio that's growing extremely fast in 2024 and going into 25. And our real goal is to really try to aim to maximize all of the output that we can get while minimizing the cost and providing the highest value for the customer. Finally, agrivoltaics is, again, growing portfolio. We have a lot of patents pending. We have some designs that are in the market today. And we really want to be the leaders in, pioneering the symbiotic relationship between solar and farming. And as we said before, all of our foundations are made in-house. So to talk about foundations, I'm going to turn to our experts and allow Jellica to introduce PRI engineering.
Thanks, Adrian. A little about PRI Engineering. We were founded in 2019, and our team has over 100 years of combined experience working with over 500 completed projects across Canada, United States, and the Caribbean. We currently have 3 offices. 2 of them are located in Ontario, one in Mississauga, one in Lindsay, which is our head office. And then we have a 3rd satellite office in Calgary, Alberta, where I'm based out of. And we also have 2 CCIL certified in-house laboratories, one in Calgary and one in Lindsay. And I'm here to talk about geotechnical engineering. So PRI, we specialize in providing turnkey solutions that are special to solar projects. We've been involved in solar farms ranging in size from as small as 120 kilowatt to larger ones that are greater than 500 megawatts. And we've been involved at every stage of the solar project, starting with preliminary feasibility site desktop reviews, geotechnical site investigations, in-depth frost susceptibility analysis that are more detailed foundation design oriented. And we've been doing field pre-production load testing for foundation design development and up to involvement in construction support for production foundation erection at the end of the project as well. And with that, I will turn it back over to Adrian.
Thanks, Jellica. This is a video I took just a couple of weeks ago when I was in northern Alberta visiting a couple of sites. Actually, no, I'm lying. There's no way that polar bears could have withstood the minus 30 degrees Celsius it was when we were on site there. But let's look at why polar racking is very prevalent and where are we on the map when we look across North America. So if we were to look at the map on the screen right now, you'll notice that we've installed all throughout Alaska, the Yukon, Northwest Territories, Nunavut, and all along the US and Canadian border. That highest dot on the top left near the Alaskan border there is the mining giant Rio Tinto, and that is situated just 200 kilometers south of the Arctic Circle. So I would venture to say that we probably have the northernmost project in the world, but probably have to debate that with the Scandinavians and Russians at some point. We're primary all over the Northern Territories, and that's where a lot of the mining takes place in Canada. And they rely, solely on fossil fuels to power their mines and resources. But polar racking managed to develop quite a few projects there to complement that now. Like most of our northern solar projects, fixed tilt ground mount is the ideal mounting solution. And that's basically based on, the frozen tundra, as we call it. But a lot of these projects, we were able to design Gabion baskets, so that like a geoballast, because of the amount of rocks available on site, which made it a very sensible and cost-efficient choice. So let's look exactly at what are the different ground conditions and what do we need to design. So Jellica, do you mind running us through some of the design considerations for northern climates, please?
For sure, Adrian. Okay. So designing for ground conditions. When we talk about ground conditions, we talk about foundation risks, and that's mainly because of the uncertainty in the ground. it's very different when we're dealing with solar farms as opposed to other conventional structures, because with solar farms, we're talking sheer amounts of foundations. For example, one site here in Alberta, one of the largest sites, we're dealing with 10,000s of foundations. And so when you're thinking at that scale, the savings that you can have for one pile and translate it over to 10,000 of piles, it can really result in a large saving for your projects. So managing foundation risks is one of the biggest things you can do for your development. And how we do that is by doing appropriate investigation of the subsurface conditions and completing pre-production foundation testing programs. And I can share with you one of the sites that I've been to where in one location, there was bedrock close to surface, and I walked 3 meters over to another pile, and we suddenly don't hit bedrock for another 3 meters below ground surface. So the difference between those two foundation types can be very critical, and especially if you're looking at a scale of thousands of foundations. And so here in solar, the conventional geotechnical engineering approach may not be adequate. It may not effectively manage your risk, and it most typically will develop into conservative designs, because managing foundation risk is about reducing your uncertainty. So completing the right activities, such as those listed here in this slide, is a good start. So step number 1, completing your geotechnical investigation. That involves either test pits or boreholes. And if possible, we always suggest doing a bit of both, because they are different types of investigations. So test pits, you have excavations, larger excavations where you have more visual on the types of obstructions that you can encounter. Whereas with boreholes, it's a smaller 6-inch hole. It's you're able to go deeper, but you have less visibility of obstructions that could be larger than your 6-inch hole. So having a bit of both is always the most ideal method for geotech investigation. And then based on the test pits and boreholes, which is the first step, we determine the ideal type of foundation for those ground conditions. And that can vary very vastly. So one of the most common ones we have driven foundations and helical foundations. Currently out in the Western Canada, helicals are currently the most common foundation type that are being installed. Driven foundations are also quite common in the east, where we have glacial till and as well as some shallow sedimentary bedrock. Ground screws are becoming more common in northeastern United States, where we also have some shallow bedrock conditions, and we start thinking about how to reduce risks of refusals. Micropiles. So micropiles involved drilling a hole and placing concrete for the foundations to get more capacity. So this is used when you're not able to get adequate capacity from your subsurface soil. And it does come at a pricier standpoint, but it does increase your soil capacity. And finally, we have ad-freeze foundations. So for sites in the Northwest Territories where we are dealing with permafrost, sorry, one slide back. Yeah, so ad-freeze foundations are what we use for sites in permafrost areas where we don't have bedrock. And then just real quickly, other design parameters that we should be considering when developing foundations for racking is making sure that you are using site-specific local climatic data that is tailored to your site, as well as considering racking-induced loads, which Adrian will be summarizing a few slides later. And then thinking about constructability of those foundations and performing pile testing to verify the capacity of the piles and for design optimization. Thank you. We can move to the next slide. And I can't move further without talking about frost uplift, especially if we're talking about cold climate regions. So the biggest phenomenon that could affect your foundations for your racking system is frost uplift. And this happens when the soil freezes and the pores between your soil grains expand due to the freezing of the pores, and that results in upheaval of your pile that is embedded within the ground. And in the second picture here, you can see an example of what happens during frost uplift. Here we have a micropile concrete foundation in Eastern Ontario. It's not one of ours, but we found this example to show you what happens when you do have upheaval of your foundations. So when any of your piles heave up, it can cause differential movement between your piles, and that stress translates over to your racking system. And on the third picture here on the right, you can see what happens when the movement of the piles exceeds that threshold that your racking system can tolerate, and you start getting some permanent damage in your racking and your modules. Okay, so one of the things we wanted to relay at this webinar is if you're really thinking about managing that foundation risk, that it doesn't end at the IFC drawing. So doing the geotech investigation is the first step. That helps us develop the foundation design, but it doesn't stop there. So again, when we're talking about 10,000s of foundations, what we do at the pre-production setting, where we only do maybe like 50 probes, once we get to the real scale, now we're talking about thousands. And again, reducing that uncertainty in the ground means you have to be more involved throughout the stage of the project. So a rigorous quality assurance of the pile erection means we don't have to test all 10,000 foundations, but we do encourage recording detailed QA/QC notes of the installation. That way, if issues do arise, we have data to go off of to address those issues and come up with alternative solutions. Third, it involves verification of the design. So making sure that after the design stage that it's actually being installed to our specifications is another factor to consider, because if it's not built to the right specifications, then it can introduce other sets of issues as well. Okay, doing load testing at the production level allows us to inspect non-conforming piles. When we develop an IFC, typically we develop it assuming an average set of conditions. And when you're looking at 10,000 foundations, there could be more piles that you can pass if they're, let's say, marginally less than the design requirement, but they could still pass with further load testing. So having a testing program allows us to reduce the number of remediations that could be required at the end of construction. And another point here is deflection tolerances. So typically, when we design for foundations for racking, the industry standard is to assume 1 inch of maximum deflection laterally and vertically. But with Polar, because Polar has been able to do more detailed analysis of their systems, we know that the actual deflection tolerances are much greater than that, and that allows us to push the boundaries further with the foundation optimization is if we know the actual tolerance of the racking system before it translates to any permanent damage. And here on the final slide is just to show you the different foundation options. We talked about helical piles. We talked about a grouted pile or a micropile, which involves concrete. And this solution is typically more expensive as soon as you bring in concrete materials. It could be 2 or 3 times more costly than the regular straight foundation. So on the third one, we have a an example of a driven post. The bottom left here, we have precast ballast. So in certain conditions where the soil capacity below ground surface is not adequate, then we may look into ballast foundations, which could be precast concrete or placed on site. It could also involve geoballast, which is sort of like a gateway basket where we have rock instead of concrete. And then the sixth option here is a ground screw. So ground screws could be used in areas where you have more cobbles and boulders, wherein a helical pile would have resulted in more refusals. So, or a driven post as well. Ground screws are able to shed more through more obstructions, and with some pre-drilling, it could penetrate through soft sedimentary bedrock as well. And that's it for me. I will turn it back to Adrian to talk about environmental loading.
Awesome. Thanks, Jellica. And that was a great reminder about, being able to not only provide like the geotechnical services, but the pre-production tests, full testing, and even on-site at construction. Having PRI engineering in collaboration with Polar Racking is sometimes a match made in heaven, along with our construction with our group for PESI, which I'll talk about in a moment. Before I go on about the loads, I just want everybody to know, like, I see a lot of questions coming in the group, so thank you for that. Keep them coming. We really look forward to being interactive in 5 minutes. I'll try to wrap up really quickly here. And I also saw a couple of hands up, so we'll get to that. We just want to get through all the slides to make sure that we cover all of our material, and hopefully they answer some of the questions that are there. But if not, we look forward to interacting with you at the end. So just looking at some of the load factors, we know that, wind, snow, frost are all factors in building in northern climates. If we look at the overall system for solar, if you look at the inverters or the modules, there's not too many variables or factors that go into how they are designed. But, when it comes to foundations and racking, there's a lot of factors that go in. So it's definitely one of the harder parts of designing the overall system. For fixed tilt, it's really just a balance of, we look at the thickness of the purlins versus the number of A-frames, and we're always trying to maximize the value of the project, and trying to really maximize the module to post ratio, if you want to look at it that way. Other factors that come involved are, the tilt angle, the leading edge. We look at the module size, the string size, and everything else that's listed on the slide, as you can see here. With regards to wind, snow, and frost, based on our wind tunnel study, our system can withstand wind loads of 150 miles per hour and above. Snow accumulation is not a concern for our tracker because, as you know, we have a controller, and a controller is designed to dump snow both east and west. Alternatively, depending on where we program it, for the most part, we try to program it at 3 inches. And they've been designed for up to 100 PSF based on our database. Our primary consideration for snow and site maintenance, it really is ensuring the right leading edge to prevent interference with a table that's going to be tilted at 60 degrees to interfere with any kind of bank snow that's underneath the system. Building in the north really requires robust solutions. So we do really pride ourselves in customizing all of our products based on, the environment. And seeing that we've been building in harsh Canadian climate for quite some time now, we feel that we are literally the experts in the field. Our ground mount system allows for very high adjustability and high construction tolerances, which is always very handy, especially when you're dealing with very strict ground conditions, and having those tolerances really helps out our construction team. We have the options for direct bolting, top clamp, or V-clamping, which is something that's relatively new and we really appreciate it in the field today. Our purlins have allocated slots, which are customizable, and holes for effective wire management, but it's also there for drainage when need be. Our tables are highly customizable to really maximize production and optimize layouts. fully adaptable to any and all foundation types, like Jellica went over a few slides ago. And again, all those foundations are manufactured in QA and QC in-house. And as I mentioned before, not only can we offer the geotechnical services, pre-production services, but the foundation, the racking, but also the construction. So we can do all of the mechanical scope of work up until bolting on the panels to the racking. Other factors to consider are obviously corrosion, snow, wind speed. For wind speed, we're really looking at the uplift, compression, and rotational movements. Those are all strong foundation considerations. The galvanization levels for both above and below grade are quite important. For below grade, obviously, we're looking at the soil corrosivity factors, and above grade, the proximity to salt water and any type of corrosive factor that can help or that can lead to rusting and racking. All of our systems are certified through bankability report done through Lattice, and again, fully certified, whether it be our single axis tracker or our fixed tilt and carport solutions. Feel free to reach out to us if you need any of those bankability reports for future projects. Finally, we'll just do a couple of slides on O&M and the importance of operations. So we really are trying to save a lot of time at the construction phase, whether it be our single axis tracker or our fixed tilt. As of today, with our single axis tracker, our racking is extremely easy to install, and we work with a lot of reputed EPCs and subs who love working with our system because as of today, 70% of our tracker can be pre-assembled prior to even shipping it to site, which is great for states where you have prevailing wages, or if you have any union type labor. On the next slide, you'll see that we're able to save up to 36% less time and labor for these pre-assembled kits, which results in a lot of savings on the construction side and maintenance side. And again, moving on to O&M, we all know that O&M is extremely important when it comes to single axis trackers. A plan really needs to be in place prior to setting up your system and really setting up monitoring as a priority. All of our drive units have been tested and warrantied so that there's no greasing or replacement of required parts for the lifetime of our product. We'd like to be, I would say the lowest maintenance single axis tracker in the market today. And we can, show you some more details of that moving forward. Finally, I'm going to finish off with a case study, which was a hurricane that took place in the northeast of North America in 2022. So this is Hurricane Fiona, which hit the east coast of Canada and Atlantic Canada in 2022. As you can see in the article here, it was definitely a historic event and caused a lot of damage to buildings, commercial facilities, but also a lot of solar farms. The good news to report here is we had 0 damages with our design, but a lot of other sites were heavily affected. And actually, when we look back at some of the sites that we were building at the time, a lot of the EPCs were wondering, like, why was it taking us so long to get our pre-production done and our geotech, and even from an install perspective, it was taking roughly 10% longer. And when we look back at after Hurricane Fiona and all the disaster that happened, it definitely was worth doing our pre-production testing and making sure that we had everything right with our foundation calculations and design, because the results were quite different, from our solar farms to some of our competition. So if we look at some of the sites that were in Nova Scotia and PEI, obviously they weren't designed for these harsh conditions. And as a result, there's a lot of incremental costs for the owner of this project to get it back up to the productivity levels that, were pre-Fiona. If we look at some of our sites around that region, so looking at the province of New Brunswick, Nova Scotia, and PEI, on the next slide, you'll see that none of our sites had any issues with Fiona, and no damage was caused to how many sites here? Just over 10 sites across the Atlantic region. If you go to the next slide. Marlene, next slide. Okay, perfect. So yeah, this is just kind of, summarizing with winds of up to 177 kilometers an hour. None of our sites were at all affected because of our strong design and foundation and racking. And finally, one of the biggest sites, this is just an email example from the owner of the site, who literally went to visit the site because they didn't believe any damage was caused after seeing reports on the news, and snapped a picture and emailed it to us, and just really wanted to express their thanks for putting in the right engineering into the foundation and the racking, and save them a lot of headaches and money post Hurricane Fiona. Finally, I just want to make a selfish plug here. Please visit our website. If there's any projects that you're working on at the moment, simply click on the request a quote button and submit that, whether it be for carports or fixed tilt or agrivoltaics or trackers. We'd love you guys to follow us on social media, on LinkedIn and everywhere else, YouTube. And from here, I just again want to thank you guys for your time. And we're now going to pass over to the Q&A session, where I'll get Marlene to lead and invite Sam to join us, our VP of Operations.
Thanks very much, Adrian. And just wanted to thank everyone for joining us today, and apologies that we started a little late, but we appreciate your patience and for joining us. So just wanted to open it up to questions. There is a chat feature at the bottom of your screen if you wanted to type anything into that Q&A area. And we have a few questions that have already come in here. So the first one that we'll address is, are sleeves mandatory for all northern climates? Angelica, would you like to handle that one?
Sure. The answer is no. It's very site specific, and it depends on your ground conditions. We, as much as possible, our primary design, we try to design without frost reduction method and leave those method as a backup. So that during construction, if there is any unexpected ground conditions, then we can have that in our toolbox as a remediation method. And maybe to explain a little bit what sleeves are. So sleeves are just your typical Schedule 80, Schedule 40 PVC sleeve that you slide onto a round pipe that creates an interface between the frozen soil and the steel, and effectively reduces the frost add freeze bond between those two. And that ends up reducing the design load and hence helping us with frost reduction.
Okay, thank you, Angelica. There's another question here that's asking if pre-drilling is required for ground screw installations, and when to know if sand should be applied for backfill.
Okay, so specifically for ground screws, we would advise against pre-drilling the site fully prior to the ground screw installation. And that's because once you pre-drill location, then that disturbs the natural your native soil. So, and it's no longer comparable to what we would have expected at the preliminary design stages. So we would only advise using pre-drilling measures if you've tried to install a ground screw and you've hit an obstruction on, say, a boulder or shallow bedrock. So if that native installation does not work, then we would recommend doing the pre-drilling to be able to get your screw to penetrate and reach that minimum design embedment depth. Now, I think the second part of the question about applying sand, similarly, so when you do pre-drill the hole, we would recommend after pre-drilling to install the ground screw without placing any backfill first, because as soon as you place the backfill, it's like a trial and error. One, it could lead to refusal again if you place too much. Secondly, applying sand. So sand is a coarser type of soil material. So even if the previous native material was fine, once you start placing a coarse material, that means your add freeze pressures are larger when you have coarser material. So it drives up your frost uplift loads higher than what we have initially anticipated. So applying sand is not recommended from the get-go unless it's required.
Okay, thank you, Jellica. There's another question here that's asking if we could show some information or schematic on how our fixed racking is adjustable due to ground settlement or frost heave. Who would like to tackle that? Adrian?
Yeah, I think it would be best. I don't know if we have the schematic right now, but with our system, with our single access tracker, we have a different method of connecting the tables. We have a modular design, and all those tables get connected by something we call it a flexible drive shaft. So it's not a rigid torque tube. What that allows for settlement, and then you have what Adrian was referring to in the presentation. We have those T assemblies, and those T assemblies have something we call it the bolt bearing, and they would always look eye to eye. If you have a settlement of 2-3 inches, whatever that case is, they will always look eye to eye, and be on the same almost level. When it comes to the fixed tilt, in our fixed tilt system, we do have adjustability, and we have allowance in our east-west beams, and we allow for also a settlement of almost 40 millimeter, which is closer to 2 inches as well. But I don't have the schematic right now, but happy if you reach out to us, just send us an email. Happy to schedule a call and go through this with you on a more technical note.
Thanks, Sam. There's another question here that, or comment, I guess, around Polar Racking appearing to be the only tracker vendor on the market offering single screw foundations for trackers. Why is Polar able to do this, and why aren't other vendors comfortable with this foundation approach?
Yeah, that's actually a great question. The main thing is because of our ability to stow. We don't have a torque tube. When you have a torque tube, you need something to protect that torque tube from something we call it torsional galloping. With our design, we don't have a torque tube. We do have an actuator that is attached to every single pile. With that, it allows us to stow flat. So in case of a wind event, we don't actually stow with an angle to protect the torque tube, and therefore we face the winds. We stow flat, and we require much less. It applies much less loads on the single access tracker product, and therefore you need less foundation and less embedment depth.
Thank you, Sam.
And again, feel free to reach out. We do have some pictures and some drawings to kind of back up this.
Okay, we have another question, perhaps for Jellica and the PRI team. How do we conduct geotechnical investigation on decommissioned landfills?
So on decommissioned landfills, typically at the end of the landfill, they would have put a cap or a cover, and that consists, it could be of compacted soil. So it's not actually as bad as we would initially think. We are able to track the surface of the landfill with track mounted drill equipment if we want to do some geotechnical investigations there. So that the how is not really a concern. It's more of are we able to, if the developers are going to allow us to actually penetrate through that landfill cap, because it could be an environmental concern, or it could be an owner concern. But the how is actually not a big issue. There are track mounted drill rigs as opposed to using trucks. So that just means we are distributing the load of the equipment across tracks to minimize the pressure on the ground. So, and that's also what we use on regular farmer sites here in Alberta, where we could have underground pipelines, and we're actually limited to crossing those pipelines to only using track mounted equipment with very minimal ground pressures.
Thank you, Jellica. We have another question here asking around ballast options, if they are available for both fixed tilt and our tracker. Does it include the 30-degree slope tolerance for tracker?
Yeah, absolutely. So I think we're happy to say, and we have a very unique product that we're the only single axis tracker manufacturer that can supply this with a ballasted design. We 100% we have a ballasted design for a fixed tilt, and we have a ballasted design for a single axis tracker. And with the single axis tracker, I'm not sure what the 30-degree is, because the single axis tracker can go from 60 to 60. So with our ballasted design, you can go from 60 east to 60 west degrees, 60 degrees of a tilt angle east and to west, and it can definitely accommodate that. With the fixed tilt, with the various designs, we've done anywhere between 15 degrees to 45 degrees with a ballasted design, whether that is a concrete or geoballast, to Adrian's point earlier in the presentation.
Thank you, Sam. Another question we have here is around what is the most optimal angle for panels in northern climates, particularly Canada, to balance production capacity and for snow accumulation, so it slides off the panels?
Yeah, and in northern Canada, what we've seen, again, at the end of the day, we're not the developer, we're not the owner. From a racking perspective, we can design whatever tilt angle that the developer and the owner may desire. But what we've seen in those areas, we've seen anywhere between 35 degrees to 45 degrees actually of a tilt angle, just to allow for the snow, if it accumulates on the system, it has enough room and it has enough slope, to kind of slide and clear the panels. So whether that is optimal from a racking perspective, yes. You want to make sure that you have enough leading edge. Your leading edge should be about 1 meter or 39 inches. Again, to allow for the snow, to give a little bit of space for the snow to slide down and maximize your production throughout winter days.
Thank you, Sam. One more question here is around what racking solution would you suggest for bifacial solar panels?
Yeah, I think the answer is both fixed tilt and single axis tracker. With our fixed tilt, actually, we've done a lot of analysis and the gain of our bifacial, by the gain of the bifacial modules. And with our single axis tracker, we do have studies and we do have lab experiments on how we can improve the bifacial and boost your production of the project by installing bifacial modules. We have in our design, we have allowed for a little bit of increase in the height between the purlin and the bifacial model, to allow for all the albedo to hit the module from the back, again, to maximize your energy harvesting. We can definitely share those reports with whoever is interested. So again, please reach out to us to the email sales@polarracking.com, or just reach out to your sales rep, and we'll get you those reports and send them over to you.
Okay, Sam, thank you very much. So team, it looks like we'll take one more question here, given the time. Last question here is for gravel fill or in place ballasts, are the baskets metal? Any concerns about corrosion?
For the gravel, yeah, we do have metal baskets. Obviously, those metal baskets are treated and very well galvanized, depending on the location of the project, whether it's in northern climate or whether it's near the water or whatever the case is. It's galvanized in the same equivalent way that we galvanize our racking, and we warranty it for the next 25 years. So there are no concerns of corrosion, only because they get treated equally as we would treat our fixed system.
Okay, thank you very much. All right, so I just wanted to thank, first of all, of our speakers for joining us today, and to thank all of you for joining us for the webinar. And just wanted to advise that if you still have any outstanding questions, to please feel free to reach out to us. Our contact information is listed here at the end of the webinar, sales@polarracking.com or info@priengineering.com. And also just to advise you that a copy of the webinar will be available very shortly following today's session. So thank you again, and have a great day, everyone.